Chapter 10 in our textbook begins a discussion of a topic called correlation and regression. Section 1, which we're going to take a look at in this video and the next, deals specifically with the idea of correlation, whereas the project that we're going to take a look at using Microsoft Excel will address the concept of regression. So let's take a look at correlation right here. The concept of correlation is built around the structure of a scatter plot. Now, we know what a scatter plot is from other math classes that we've taken or other portions of even this class that we've taken a look at things such as this. But what does a scatter plot do? It just takes two variables, in this case, hours of study, which is X, and your grade, Y, and plots them against each other on an XY coordinate plane. Okay, so the question here is there a relationship between the number of hours that you study and the grade that you get on a specific exam? Now I'm going to look at my X's, and I see that all of my X's are from 1 to 6. So I'm just going to go ahead, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. Along my X, and I notice my Y values are all up in this range right here. The lowest one is 57 up to 88. Now, got to be careful with scatter plot. We typically always want to start at 0. So I'm actually going to go 10. Actually, bring that down a little bit. 10, 20, 30, 40, 50, 60, 70, 80, 90. We'll go up to 100. So what I'm now going to do is I'm going to take and plot these coordinate points, 682. So I'm going to go out here to the 6, and I'm going to go up to about 82 and put a point. Then I've got 263. So I'm at X equals 2 up to 63. I'll put a point there. 157. 1 and around 57-ish. Then I've got 588. So here out at 5, and I'm going to go up to 88. It's about right there. 268. 268 is right there. Last but not least, 375. That's about right here. So what we do, took our coordinate points, which is showing the relationship between hours studied and grade, and we wanted to see if there was a relationship. The mathematical way of saying that is there a correlation between the two variables. Now, in this section, we're going to start by determining whether or not a relationship or a correlation exists, but just by simply looking at it visually. I can see here that there's a trend. There's a trend that the longer I study for the exam, the better grade I'm going to get on the exam, right? And conversely, the less I study, the worse I'm going to score on the exam. Okay, so I can kind of see the relationship here. A concept that you may have recalled from past is something called a trend line. That would be the same way of taking a look at something like this, where can I draw a line through this data that represents it or follows the pattern fairly well? And I can. We're getting ahead of ourselves, though, because a trend line gets into the topic of regression, where we're still just focusing on correlation. Okay, do we observe a relationship on the scatter plot? Okay, so there's an introduction. So what about types of relationships? There's a nice figure, 10-1 in our section 10.1, which shows different types of relationships. Notice this first top left corner one, positive linear relationship. Then we here have negative linear relationship. But our relationships aren't always linear. Usually they're positive or negative, but they're not always linear. Here, notice it says we have a curvilinear relationship. You can still see and visualize a relationship between, but it's not a straight line, it's a curve. Now, curvilinear relationships actually come in a lot of different varieties. Curvilinear can come as logarithmic, which tend to look something like that. They can come exponential, which tend to be equations or patterns that follow that pattern. Or they could be power. What this implies is something like a quadratic, or maybe even something like a polynomial of third or fourth order. Okay, so we don't have to have just linear relationships. We can have curvilinear relationships that follow several different types of function families. Okay, or we can just simply have no relationship. Is the data so scattered that there's no observable relationship between the two variables? Well, let's go ahead and take a look at another example here. In this case, instead of taking a look at number of hours studied in the final grade, it's, well, what about the number of absences in a final grade? So my x's still, I'm going to go from 0 up to largest value here is a 15. So maybe I will count by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18. And then my grades here, I go from a 43 all the way up to a 90. So I'm going to count by 10s again, 10, 20, 30, 40, 50, 60, 70, 80, 90, and we'll go up to 100. And we're going to really quickly plot these points. So 682, so someone with 6 absences scored an 82 on the exam. Someone with 2 absences scored an 86 on the exam. Good. Someone with 15 absences scored a 43. So 15, obviously not performing as well. Someone had 9 absences, scored a 74. It's about right here. Someone with 12 absences scored a 58. Someone with 5 absences scored a 90. Good for them. And someone with 8 absences scored a 78. Now, do we see a relationship here? Yeah, we do. And specifically, we see that unlike the first one where there was a positive relationship, meaning looking from left to right, things were growing, here we have a negative relationship, and what I would call a negative linear. This example right up here in this chart that we looked at. So we got a negative linear relationship. So can we construct a scatter plot, and observing the scatter plot, can we determine just visually, is there a relationship, is there a correlation between the two variables? Are they interacting with each other in a way that is meaningful? Are they related to each other? Okay, well, one more example here, and it is number of teachers in thousands and pupils per teacher. And so school district number 1, they have 7,000 teachers, and they average 12.4 students per teacher. And so we put that dot on the scatter plot over here. This school district had 34,000 teachers, and they averaged 14.3. So we went down and we plotted all of the coordinate points, comparing our x and y variables here. And this is the chart that we came up with. Well, taking a look at that, no observable pattern there. So what we would say is that there's no observable relationship, or there's no correlation between the two variables. Now at this point, all we're doing is taking a look at it visually. We're looking at a scatter plot constructed that shows the visual relationship between them, and trying to, from just observing it visually, can we determine whether or not there is a correlation, a relationship between the two variables. This is valuable, but it's also valuable to develop mathematical ways of determining if a relationship exists, or maybe a better way of saying it is how strong of a relationship exists. So the next video that we're going to look at will address how to accomplish that.